Okay, so we're taking a look at the simplex method in this video, the simplex algorithm. And I should say that what we're going to be doing first is just looking at an example and kind of setting up all the pieces to this algorithm. But the idea behind it, the steps, I guess step one would be to do some pre-processing, and I hate to say that, but we want to create, but before we even do that, we want to put LP in standard form and create a tableau, what we're going to call a tableau. Okay, and then in the what we're going to do next, this is really the main step. Maybe I'll say that this is step 0. So then really the step is get a BFS. Evaluate Z. Okay. Now we need to determine if optimal. If it's not, then we want to determine or find an adjacent. Maybe I should not put this all in one here. Somehow we need to determine if it's optimal. Okay, here we go. Then if not, find an adjacent. BFS that gives a better solution. And this is important. There's two important things here. It's adjacent and you must get a better solution, right? So what that means is that as our algorithm progresses, the value of the objective function gets better and better and better and better. Okay, so that's a really important step. Good. And then repeat. Good. At some point you're going to run out of basic feasible solutions, right? All right. So let's do this by example. So the example we were working with is to maximize z equals 6x1 plus 5x2 such that x1 plus x2 is less than or equal to 5, 3x1 plus 2x2 is less than or equal to 12, and x1 and x2 greater than or equal to 0. Good. So the way I want to write this in standard form is I'm going to actually write this in kind of a weird way. Z minus 6x1 minus 5x2 equals 0. So this is now my objective function. And underneath of here, I'll go ahead and, let me get some space here for my slack variables that I'm going to need. And so now my first constraint is going to be x1 plus x2 plus s1, right, equals 5. And the second constraint will be 3x1 plus 2x2 plus s2 equals 12. Good. All right. Now, you'll note here that, let's see, maybe I'll go ahead and rewrite this now in our tableau. This is going to be what we're going to be calling our tableau. And that's just an easier way to write these things here. Now, sometimes you can leave off this first column. Some people like to leave it on. Doesn't really matter. Right hand side. I like to put the variable names up on top just so I remember what I'm doing. And then up here we'll put our 0, minus 6, minus 5. I'm just writing these down from the top here. And then 0 for S1, 0 S2. And then actually the right hand side is going to be 0 when we finish. It's not, I don't know that it's going to be 0 yet, but it will be. Good. Oops, I guess some people put a 1 here. Okay. trying to decide whether okay, we'll think about that. So this column actually never changes. You can leave it off if you're looking for a quick way to write this tableau. But down here is just going to be our matrix A from the standard form, and then here is our right hand side B. Good. And so this is the simplex tableau right here. Good. Now, the way this starts is I want to find a BFS. And the easiest way to do that is to look at the matrix A to see if we have the columns of the identity. Boy, my voice is going out. If so, make these columns our basic variables. Right? So in this situation, we see that S1 and S2 are the first two columns of the identity. So our set of basic variables will make to be S1 and S2. And in that case, by the way, our NBVs are X1 and X2, and these are set to 0. Right, so our solution is going to be X1 equals 0, X2 equals 0, and then what's nice about having the columns of the identity as your first solution is that you can read what the solution is right off the B, right? Because here we see S1 is equal to 5 and S2 is equal to 12. Good. And so our solution right now is X1 equals 0, X2 equals 0, S1 equals 5, S2 equals 12, and then Z is equal to 0. Excellent. All right. Now, let's get rid of some of this stuff here. Now the question is which variable should come in next? Now remember, to get an adjacent BFS, I can only change one of my basic variables at a time, right? And so I can choose either S1 or S2, meaning I can just bring in one variable. And if I look at my row 0, let me circle that in red here. This is row 0. Then I want to bring in the coefficient that is most negative. And do you remember why that is? Because if we bring this back, the most negative coefficient corresponded to the most positive in the original problem, right? So this -6 came from here, and that came from here. Good. And so let's say that again. Which variable should I bring in? Bring in the variable that is most negative in row 0. Okay. And so in this case, that is X1 equals well, X1. So we're going to bring in X1 as a basic variable. Good. All right, so now the question is how big can X1 be? Or another way to think about it is, if I bring in X1, should I get rid of S1 or S2? Well, let's see. From this table up here, I see that X1, or sorry, I should say that S1 is equal to 5 minus X1. I could say minus X2 here, but because X2 is going to be equal to 0, in fact, let me go ahead and say that for now. And then this is going to be 12 minus 3x1 minus 2x2. Now because I'm deciding to bring in x1, I can go ahead and set x2 equal to 0. And so now the question is, I'm trying to figure out, should I use x1 to replace s1 or use x1 to replace s2? Well, I want to increase x1 as much as I possibly can. Right, so from the top, I can make x1 equal to 5 before s1 becomes negative. Right, and in the bottom, I see that I could bring in x1 to be equal to 4 before I start to become negative. the problem with making x1 equal to 5 is that that would make s2 negative, and suddenly our solution would not be feasible. Okay, so therefore you have to choose the smaller of the two x1s here, and so we're going to choose x1 equal to 4. Oops, sorry about that. And if I choose x1 equal to 4, then that makes s2 equal to 0, which means that I'm replacing s2 with x1, right? Good. And so what that means up here in our tableau is that the second constraint is our pivot position. And so we're going to pivot here. Okay, so instead of having the second column of the identity here, right, we're going to make it the first column over there. All right, so gosh, have I run out of time already? It looks like I have. So I'm going to go ahead and stop here. I hate to stop right in the middle of the example, but we'll pick it up in the next video.